Hi students, in the previous chapter we had studied a lot about mixtures. We had studied that mixtures could be solutions, colloidal solutions or even suspensions. In this chapter we'll study in detail about the solutions, colloidal solutions and suspensions we had just touched in the previous chapter. Understood? If you take solutions, they have very tiny particles like this. Colloidal solutions on the other hand have slightly larger particles like this, and then suspensions have even larger particles. But what exactly are colloidal solutions, suspensions and only solutions? What are their properties? What are some examples of these things? We'll study all that in this particular chapter. The meaning of a solution. Here we go. The meaning of a solution. First of all, as we begin this chapter, let's learn about what a solution is. You see, we'd studied earlier that mixtures can be divided into three types: solutions, colloidal solutions and suspensions. What exactly is a solution, the first type of a mixture? Here's the definition. A solution is a homogeneous mixture of two or more substances. You might have thought that the definition of a solution will be a bit more complicated, but it's actually quite simple. A solution is simply a homogeneous mixture of two or more substances. In fact, even though we think of solutions in terms of, say, a solution of salt in water or a solution of sugar in water, solutions can be of any type. They can be solid-solid, liquid-liquid, any two substances which are mixed homogeneously, that is, which are mixed uniformly, so that each substance completely fills up the other substance. That's a solution. A solution usually consists of two parts: a solute and a solvent. The solute is the substance that dissolves in the solvent. So the component in lesser quantity of the uniform mixture is called a solute, and the component in greater quantity of the uniform mixture is called a solvent. So basically, you can say that if any two substances are mixed, then the substance that's in the lesser quantity will be the solute and the substance in the greater quantity will be the solvent. If you mix sugar in water, sugar will be the solute and water will be the solvent. Understood? That's quite simple. So I'll repeat the definition of a solution for you. A solution is simply any uniformly distributed homogeneous mixture. What this means is that in a solution, all parts of the solution contain the same proportion of the components. For example, if you take sugar water, all the parts of sugar water will have the same amount of sugar and same amount of water. Understood? Because the mixture is homogeneous or uniform. So any such uniform mixture is called a solution. Let's consider some more examples of a solution. Here we go. One of the most common solid liquid solutions is sugar water. Of course, you must have tasted it sometime in your life, right? What's the solute in sugar water? Of course, the solute is sugar. And what's the solvent? It's water, of course. So you can see that sugar water is a homogeneous mixture with sugar as the solute and water as the solvent, because sugar dissolves in water. We can similarly have tincture iodine. Tincture iodine is a mixture of iodine and alcohol. Have you heard of tincture iodine? It's generally applied on wounds to heal them fast. The substance you see on your screen here is iodine. This powder here, it's the solute. When it is dissolved in alcohol, this substance called tincture iodine is formed. You can see a picture of tincture iodine on your screen right here. Again, in this case also, the solid, the iodine crystals are the solute and the alcohol is the solvent, because it's present in a great quantity, isn't it? Now you must have thought that there are only solid liquid solutions, or maybe at least liquid solutions. But did you know that there are even solid solutions? Yes, there are. In fact, solid solutions are often called alloys. Brass, for example, is an alloy that contains zinc and copper. Zinc is the solute and copper is the solvent in this case. This might seem really weird, isn't it? After all, how can a solid dissolve in a solid? But when you melt two metals and then when you dissolve them and solidify them, alloys are formed in many cases. In this case, brass is an alloy of zinc and copper, and this is a solid solution. As you can see, this picture you can see on your screen next to the word solute represents zinc, and this orangish red metal that you see, it represents copper, and brass is an alloy or a solution of zinc and copper. We can also look at liquid solutions. Again, vinegar is a wonderful example of a liquid solution. Remember vinegar, which we use to spice up our food? It contains acetic acid, and it also contains water. Acetic acid is present in a lesser amount and water is present in a large amount. So you can say that acetic acid is the solute and water is the solvent. Simple, isn't it? So you can see that there are liquid solutions, solid solutions, solid liquid solutions. But the one common trait in all these mixtures is that the mixture is homogeneous. So if acetic acid is dissolved in water, all parts of this liquid solution, vinegar, will contain the same amount of acetic acid and water. You cannot distinguish acetic acid from water in this mixture. Here's another example of a solution. A gas liquid solution. Aerated drinks, soft drinks, your very own Coca-Cola, all these drinks are examples of gas liquid solutions. Why? Because clearly carbon dioxide gas is dissolved in water, isn't it? That's the basic component of all sodas, all colas. So clearly the solute, you could say, is carbon dioxide, and water in soda water is the solvent. So this is a gas liquid solution. The gas is uniformly distributed in the water. In soda, you don't have more gas in one part of the soda and less gas in another part of the soda. So again, that's a property of solutions. The mixture is uniform. So we've studied so many types of solutions right now: gas, liquid, solid, liquid, and solid liquid. There are even gas solutions. Can you give me one famous example of a gas solution? Well, the example is quite simple. Our very own air is a gas solution. You see, it has oxygen and it has nitrogen as major components, and you can take air from different places, but all of them will have the same amount of oxygen and the same amount of nitrogen. Understood? So even if you take air from Chandigarh, if you take air from Delhi, if you take air from Chennai, New York, the air everywhere will always have 21% oxygen and 78% nitrogen. Understood? So what you can see here is that air is a uniform mixture and its composition is the same everywhere. There are slight variations, For example, sometimes air may contain more smoke, sometimes it may contain more carbon dioxide, because of pollution. But more or less, the oxygen and nitrogen present in there is constant. The proportion remains constant. So here is a solution. So these were some examples of common solutions. Now that we've learnt about what a solution is, a uniform mixture, and different examples of solutions, let's learn about some specific properties of solutions. What are the properties of every solution on this earth? The first property of a solution, of course, is in its definition. A solution is always homogeneous. It has a uniform composition throughout.